Good afternoon, everyone. Welcome to this session. So this is a high-throughput ML session, and my name is Yu Chen, and this is Mia. Today, we're going to walk you through how we can do high-throughput ML with Databricks. And the subtitle of this talk is Mastering Efficient Model and Feature Serving. Yes, so we're going to talk about both model training and the feature serving at enterprise scale, which means high QPS. So with ML, there is a lot of infrastructure involved. And for this particular talk, let's talk about let's oversimplify this a bit to see what are the problems we are trying to achieve today. Is say, we have a classification model, which is very typical. And how can I achieve a high QPS? That's the goal of this talk. Right? You all have your models, you have your features, and how can I serve that with very high traffic load? And okay, so Mia, what kind of a model do we have today?
Cool. Thanks. Thanks, Yuzheng. That's a great question. How do we achieve 15K QPS? I will take an example to demonstrate how do we achieve this goal. We have a very typical but very normal use case we have in production. Let's imagine I'm a fintech company and I'm a client of Databricks. I'm asked to solve this fraud detection question. So this is a very simplified overview of a typical setup we have. Imagine this is a component in your whole transaction processing system, and we're asked to detect some of the transactions if they are fraud. Imagine you have clients sending us requests. We have a machine learning model returning if the transaction is a fraud. That's very simple, but normally in production use cases, we don't have all the information in the request. So we also need help from an online feature store to return all the feature values we have from an online database. So this is simple. Then how do we achieve 15K QPS? That's the main question we have. Okay. So this is the approach we are going to take. There are a couple of steps. First, of course, we need to deploy this model with the help of feature store. So the model and the feature should be connected, and it should also be hosted together. And then we will need to do a scale testing to see how do we scale this entire system to serve the anticipated traffic we want. Through the load testing, we will know which part should we scale and how much they should be scaled. And then we can productionize our product with confidence. Okay, so first step, how do we train our model with features? Databricks provide us a very simple API that can help us connect the model with the feature. It only needs 3 steps. First thing is we need to define a training set. So this is all done through the model training process. So you have a feature engineering client, that's the API Databricks provide us. And then I can create a training set with some feature lookup. So the feature lookup is a reference to some feature tables. The table is stored in unique catalog. And I also need to specify some details like what's the primary key for lookup, and in this training set, what columns are the labels. And then the second step is log this model. It basically stores this model in unit catalog. And by logging this model, we combine the model and the feature. So the model knows where the feature is, and it automatically knows if the model is served online, where to look up this online feature. And then the third step is to publish the feature table to the online feature store. You may notice that this is the only 3 steps we have, but we don't need to tell the model, deploy the model where to look up from the online table. It's all connected. That's the magical part. It's all connected together. Databricks model serving will automatically know where the online table is, because all the information is stored in this training set when you log the model. Cool. So now we have a model and all the features supported. Let's jump into some code. Cool. So in this example, I will just show you the steps I took previously for training some models. And then we will have Yucheng help like doing the scale testing to find out how do we scale the system, and then we'll see some results. Cool. First step is training the model. First thing, we should look at what data we have. So in this example, I have two feature tables. One is a user feature table, and another is merchant, because we're processing some transactions. And then we also have some labeled data. Let's take a look at the table. Data is always the first. So user table have some user ID, some features, they are aggregated features, and timestamp. Timestamp can be used for point-in-time joining. And merchant table is also very similar. It has features, ID, and timestamp. And then this is the label data we have. One of the column is like the label, which contains a Boolean value. We also have some other features. These are not stored in feature store. They only exist in the real-time traffic. This is very typical. You cannot have all your features pre-processed and stored in feature store. This is all taken care of. Cool. This is a step we have in the previous slides. Basically, you create the feature lookup, reference the feature table. And then we have a training set. So there are a couple of steps to train the model. I'm taking a very simple XGBoost classifier for this example, and I trained it with the help of the training set. Now we have the model prepared. We need to store it in unit catalog. Basically, I call this log model and pass the training set into it. At this point, the information of all the features are stored together with the model. They are bind together. So the model will work automatically both online and offline. They know where to find the feature tables. And then the last step is like to make the feature table online. This is the last step to make the model ready for serving. So how do we do that? It's also very simple. We have SDKs, but we also have UIs, which is what I want to show you. So this is the feature table we have. You can see the schema matches what we have. And then basically, you can go to create and create online table. So this is a small spoiler, what we are going to launch soon. If you want to learn more, you can come to our keynote tomorrow. But basically, it's a brand new online table we're going to launch. But for the example today, I will just use the OG online table. For the creating a online table, we'll just give it a name. For this one, I will use user feature online. You can see the primary key and timestamp keys are pre-populated. Just click confirm, and then, oh, it's already exists. So let me try another one. All right. Now we create an online table. You can see we are provisioning some resources. These resources are pipelines that we use to copy the data from offline to online. Cool. Now this model is ready. We have all the model trained and the feature table published to online. Next step is serve and scale testing.
Thanks, Mia. All right, so now we have the online feature store ready, right? And we have also registered the model earlier as well, which is XGBoost fraud detection classifier, very simple. As you can see that from the UI, it's very easy to start serving the model. Right? So we can click on this on the right side, serving the model, and it will bring us to the creation form of a serving endpoint. You might have seen this already, but let's see what we would show. You can give it a name, and the model and the version has been pre-selected. And this is going to be a CPO model. Right? The next one, well, the important piece is scale out. Right? So we can see that we can choose different concurrencies. You may be wondering, like, how do I know which one to select? Right? So we say it's a small, medium, large. What exactly should we select? And how do we choose the right one to meet our goal of 15K QPS? Right? That's the problem. Well, we don't know that yet because, as you can see, the QPS highly depends on the model performance itself. Right? If the model takes a long time to make a prediction, then naturally it's not going to reach high QPS, and unless you give it a lot of concurrency. So what we can do is the key thing of this is we need to perform load testing of the endpoint and understand what the model takes, how long it actually takes to make a prediction. So we want to start with small, right? So this is the smallest scale we can choose. So the theory is that if we know how the endpoint will perform with the scaleless scale, then if we want to increase that, we just horizontally scale out, right? So you see that if 4 concurrency is the smallest, if we want to give 4 times of that, then we would choose, say, a medium or even higher. So it depends on the multiplier based on the smallest scale, how the model performs here. So we're going to do the load testing here on this scale. And you can see that scale to 0 was enabled by default. That is usually for experimental use cases and if you want to save cost. And for load testing, we don't want to do that. Right? We want to have the model working, and we're going to stress test it. So we're going to uncheck the scale to 0 option, choose the smallest scale. And the next important piece is enable route optimization. So this is for model solving a particular mode that we will eliminate any unnecessary hops during the network. So this will be the ideal expected behavior when you have a very low latency and high throughput use case. So we want to enable the route optimization. That's pretty much it when you configure in the endpoint, right? So again, we choose the smallest scale, we disable scale to 0, and enable route optimization. And then we're going to create the endpoint. So in the interest of time, I have previously created this endpoint already. So I assume this is the endpoint that's created. As you can see, re-emphasize is the smallest scale. It does not have a scale to 0. And here it has a very unique URL for query. So this is a route optimized URL. Okay, so then next step, we're gonna load test this endpoint, right? That's the key, right? We need to know how this model performs. So this is a bit of something we're gonna roll out yet very soon, but we will see on the top right corner, we have a load test button, right? We're gonna make this very easy accessible. We have prepared a load testing notebook how to perform load tests on endpoints. We'll click on that. And yes, it will generate a notebook with necessary information to perform this. There's a lot of instructions, as you can imagine. So I'm going to start choosing the cluster, and actually I'm going to close that. We're going to have a very detailed documentation page as well, just to walk you through to understand the different concepts. But for this talk, let's just quickly go over the things that would be important to note. Okay, first, I'm going to start installing some of the dependencies. Right? But the key thing is the notebook will instantiate using the locust framework to instantiate many concurrent users to send a request to the endpoint we just created. And it will measure the performance, the latency, the request per RQPS, so that we know how this model performs. So I have installed the dependencies, and then we're gonna keep going, right? Importing some of the item libraries. And here is the configuration about the endpoint itself, but they are all pre-populated because it knows which endpoint we are created this endpoint for. So the one thing I want to notice that, yes, we need a client to authenticate with the endpoint. And we can use the service principal here, which is our recommended more standard and a secure way to query the endpoint. I have previously created a service principal with their secrets and clients, so I'm going to refer them here. So I have created this beforehand. Okay. So this means I'm going to use this identity to query the endpoint. And we're going to run that. Keep running this. So that's pretty much the only thing we want to specify. And we have a lot of helper functions included as well. So first thing is we're going to run very short test. Right? So you can run it for 30 seconds to warm it up to see how this looks. So if you run that, as you can see, this is a locust framework, and it will create a URI if you want to monitor the load testing in progress. So as you can see that it keeps increasing the requests and measuring the latency, and it will show this in real-time graph as well. You can see the RPS, or requests per second, keeps increasing as we slowly ramping up the number of concurrent users that's sending the request. So here we are simulating a real use case or traffic load to see how this model endpoint is responding. Right? So in the end, we reached about like 30 or 29 concurrent users, and we reached about 240 RPS. Right? As you can see, the more users, concurrent users sending requests, naturally the latency goes up. Right? So there is a bit more queuing happening. Okay, so that would be the warming up of the endpoints. And the next, we will see that. So one thing we want to know is for the smallest scale, so imagine if it has one replica, you can still send as many concurrent requests to it as you like, except that the more you send to it, the more requests will be queued up, right? So the latency will go up. But it also that means you can handle more higher concurrency if you can tolerate a bit higher of the latency. So here is a trade-off: is if you have a target of the latency, then maybe you can tolerate more concurrent users. What we want to do test next of this part is say, if I'm giving a range of different concurrent users sending requests to the endpoint, what results do I get? So naturally, we'd expect the more current users we send to it, the higher the latency is. But maybe at a certain point, even if the latency increases, it may be still within our target, right? That means it could be acceptable. So this request will do that and then see how this endpoint performs under the different concurrent user settings. This test is going to take a while, so every number will take like 5 minutes or so. So it's going to take a total of 45 minutes. I'm not going to do that here. So I have jump ahead of time, right? So this is the results I have previously run on a similar endpoint. And see, what we end up seeing is, yes, given the different user accounts on the small endpoint, we will see the different requests and the different average response time, right, and their distribution as expected. So maybe a better presentation is this graph form, right? Naturally, you can see the more concurrent users, the latency starts to go up. Here is where we can make the decision. What is our target here? If we look at this table form for, say, for example, for P90, right? So it goes as low as 26 milliseconds or up to almost 50 milliseconds. If we say 50 milliseconds is acceptable, that's our target. That means we could allow up to 10 users. We could accept that, right? So what the next step of the notebook is say, if this is our target, and then, so in this case, I'm going to choose 10 that represents this row. This latency target is what we accept. And this is our, say, expected request per second. How much concurrency do I need? So now you see this is the calculation. I already know the smallest scale, how the endpoint performs, and I have a target number. Now I calculate how much scale I need. So the notebook will do the perform calculation for you. It basically gives you a recommendation, right? So basically, based on the previous results and your target, you will say this is the concurrency you probably want to look at. So certainly this is not absolute number, it's a starting point as a guideline. As you can see, this notebook, you can change any part of it. If you want to change even different concurrencies or different user accounts, feel free to do so. And this is the point of the node testing. You want to try different parameters to see how this endpoint performs. But this one will give you a starting point to say, if I want to use the concurrency of 324, right, how do I do that? Now I would go back to the endpoint, And then I edit it, right? So it's small. I would go edit it. And now I know what scale I need to choose. That's the purpose of the load testing. And in this case, it's none of them, right? It's not small, medium, or large. Right, so this is the thing we actually wrote this out very quickly, but you may have experience with this before. How do I specify customer range or concurrency? We're gonna have a custom option there and let you type what you want. That's it, right? So you can type 384. Actually, that's 384. Right, so then we also choose this 384, right? If I'm continuing doing the load testing, I could eliminate the auto-scaling by specifying the same minimum and the max concurrency so that I know I'm always going to have this many pods running, right? So they're going to do that. But in a more production scenario, you may change that depending on if your traffic pattern is the time of the day pattern, then you can have a different minimum and a maximum. So it will auto-scales. So in this case, if I'm continuing load testing, I know the concurrency I'm going to test next. I specify here, update the endpoint. I'm not going to do that, but just say if you update it, it's going to update the endpoint to that concurrency. And then you would go back to the notebook. You say, now I changed my endpoint. I'm going to run the test again. Right? So that's basically the loop here. I know this is, I know what I'm testing the concurrency, and I'm going to see how much traffic I can get out of it. And here, yes, so pretty much the same thing is gonna run the locust again for a while. And this particular results, let's see what we get from last time I run it. So we have a load test report. In the end, it will give you how much requests is sent, like a failure rate or not. But most interesting thing here is the charts. So what do we end up achieving for the model is say, we actually did get you, like say, this is a 50K QPS, 50,000, that's our goal. And then that achieved about like 29 milliseconds on P50 for like still less than 50 milliseconds on P95. That's pretty good. Right? But the more interesting thing is that, yes, this is a starting point. You can keep stress testing it. Right? If you want to go higher, let's say, so naturally the response time goes up by, let's see, if in the end, what we end up doing is almost 50,000 users sending requests to the endpoint. We got like a 20K QPS. That's what we got as a highest we got, right? So with the, well, certainly higher latency. So here is again, depending on your particular use case, you want to decide what latency you want to tolerate or expect, right? Because certainly the more concurrency, the more cost it is, right? So there's a cost trade-off. The cost, the concurrency, and the latency target. So those are the ones to consider, but this notebook or the node testing helps you to decide why you're making these trade-offs and how. Okay, so that's the end of this particular demo on node testing. Right, let's go back to our presentation.
Okay, cool. Thanks, Yusheng. So yeah, that's great. It's a lot of content, but we got a really good result. We set up a goal for 15,000 QPS, but we end up reaching 20,000 QPS. Let's do a little recap on how do we scale this system. So basically, there are two components in this serving stack. One is online feature store, another is model serving. So online feature store, this is also a little like spoiler. We are providing some new options for you to tune the capacity of online feature store. So you can calculate like it's both like horizontal scaling and vertical scaling. So based on the data size you have, we have the in-memory cache that can improve a lot of performance, and that you can get the capacity unit to specify. And then to serve the anticipated traffic, we need to horizontally scale the online feature store, and this comes in with the readable secondaries. So if you read from more secondaries, each one have a fewer load. The second part is model serving. As we showed in the demo, you can enable route optimization. This gives you the best network latency we can provide. It eliminates a lot of the network hops within the system. And then selecting the proper concurrency is crucial. That gives you the provisioned capacity for serving the anticipated traffic. And the formula we use in the notebook is quite simple. It's just QPS times the execution time, aka the latency of the model. Yeah, basically with this formula, we can calculate how much concurrency we want. And then just to remember that in production, the traffic will not stay flat in most of the case. So if you are anticipating some like high traffic spikes, you can tune that beforehand. So like we can capture all the requests that we want to serve. Yeah. So basically, that's what we can scale. Yeah.
And well, this is pretty much almost the end of our presentation. Before we get to the point, Q&A, right, some key takeaways to summarize. It's very easy with Databricks to deploy more than a feature endpoints. Right? So simple as 3 steps. Right? Create the training data set, log the model with the training data set, and then publish to the online feature store. So now the model and the feature connection is established. And now with the Databricks, you can also deploy with the confidence, right? So we're going to provide you the out-of-the-box load testing environment to help you guide you through every step of the way to determine how you can achieve the target. And we have a very scalable infrastructure underneath as well. So we are constantly improving our infrastructure. So we showed a 20K example results, but we actually can go way beyond that, like as high as 250K QPS. That's not a problem. And they can go even higher on concurrency. If 1,000 concurrency, if that's what you need, your enterprise desire needs, we can provide that as well. So again, as the improvement is always underway. And in particular, I want to just plug in for tomorrow. Right? So come to tomorrow's keynote because we're going to have some interesting announcements, very exciting ones about the next steps for online feature store, and particularly how online feature store can support this very high QPS workload as well.